You know, those moments, like you really need to react in a flash, maybe slam on the brakes, or coordinate your hands and eyes perfectly when you're typing super fast for a deadline, or even just trying to picture how something fits together, like maybe that infamous flat pack furniture. I know I struggle with that one. These aren't just, random tasks. They lean heavily on some really crucial cognitive and motor skills we use constantly, often without even thinking about it. Today we're doing a deep dive into something I find truly fascinating. Could just playing a regular off-the-shelf immersive VR game actually level up these vital skills? And, what about the flip side? That sometimes queasy, dizzy feeling, cyber sickness, is that a major barrier?
That's exactly it. Our mission today is to unpack a recent study looking at engineering students, actually, over in Taiwan. This research dug into how playing a pretty popular VR game might affect their reaction time, their hand-eye coordination, and, yeah, their spatial skills, too, all while keeping a close eye on whether it, well, made them feel sick. So we'll break down the findings, cut through some of the jargon, and really see what it might mean for you.
Okay, sounds great. So before we sort of mentally strap on those headsets, let's nail down what we're actually talking about, these crucial skills. What are they, and why are they so important day to day?
Right, let's start with reaction time. Basically, it's that tiny slice of time between something happening, a stimulus like a light changing, and you voluntarily responding to it. It's really about how quickly your brain can process information and then fire off signals to your body. Think of it as the speed and efficiency of your mental wiring.
So it's not just about like how fast your hand can move, but the whole brain-to-muscle communication chain.
Precisely.
Yeah.
And what's really interesting is that reaction time isn't just reflexes. It's this whole integration of seeing something, deciding what to do, and then making the movement happen. For engineers, for example, it's super critical when they're using machinery or doing lab work. Split seconds matter. It really shows how fast your nervous system is working overall.
Okay, that makes total sense.
Correct.
Then we've got hand-eye coordination. Sounds simple enough, but what's the magic behind it?
Well, it's that amazing ability to use your eyes and hands together, right? Your hands are being guided in real time by what your eyes see. And it actually requires some pretty complex cognition. Your brain is constantly processing visual stuff and sending these super precise instructions down to your hands.
Wow. Yeah, you don't really think about how much goes into it. It's vital for, like you said, typing, driving, playing sports.
Yeah.
Basically everything. I even remember hearing something interesting. Didn't the study find a link between good hand-eye coordination in kids and better reading and math skills? Is that right?
Yeah. Absolutely. Research does point to that connection. It seems foundational not just for physical tasks, but for broader cognitive stuff too. And for engineers,
Yeah.
oh, it's essential. Think about assembling tiny components, reading complex blueprints, or using motion controllers for robots and things. Absolutely critical.
Fascinating. Okay, and the third one, spatial skills. This sounds a bit different, maybe less about direct physical action. What's this one about?
Spatial skills are like your brain's ability to understand and mentally mess around with objects in 2D and 3D space. It's being able to visualize how things rotate, how pieces might fit together, or even just navigating a new place in your head.
Ah, so picturing that tricky Lego step before you do it. Or maybe playing Tetris in your mind when packing a suitcase. Sounds like serious mental gymnastics.
Exactly. And it's way more than just, a neat trick. It's fundamental for careers like engineering, architecture, science. Developing spatial ability is actually seen as really crucial in engineering schools now. It links directly to how well students do later in STEM fields.
Yeah.
So yeah, those three, reaction time, hand-eye coordination, spatial skills, they do really form this powerful toolkit, especially for technical roles.
Okay, got it. That really clarifies the building blocks.
Yeah.
So let's move into the VR lab now. Tell us about the study itself. Who took part? What exactly did they do?
Right, the setup. They had 15 college engineering students, all based in northern Taiwan, young adults aged between 20 and 30.
Just 15.
Okay.
Now, what was the game they played? You said it was popular.
Yeah, they use Beat Saber. It's a massive hit in the VR world. If you haven't seen it, picture this. You're in this cool, neon, sort of futuristic space. You've got controllers that act like lightsabers, one in each hand, and these colored blocks fly towards you in time with music. You have to slice them in specific directions, up, down, sideways sometimes with a specific hand, and even dodge these virtual walls that come at you. It's very active, very engaging.
Yeah, I've seen videos of that. It
Yeah.
looks intense, like a real workout crossed with a rhythm game.
It definitely can be. They used an Oculus Quest 2 headset, which is handy because it's wireless, no tripping over cables. And the actual time spent playing in the study was quite short, just one single 30-minute session.
30 minutes. Okay, quite a brief intervention then.
Yeah.
Now, the crucial part, how did they actually measure changes in those skills we talked about. You can't just ask them if they feel faster, right?
Yeah.
It needs to be objective.
Exactly, you need proper tests. For reaction time, they use two main ones. First, the plate tapping test, the PTT. Imagine drumming really, really fast, but back and forth between two circles set about 80 centimeters apart. They timed how long it took to tap back and forth 25 times with their dominant hand.
Yeah, okay. Like a speed drill for your hand. Got it. What was the other one?
The other was Dittrich's ruler drop test. This one feels more familiar, maybe. It's basically trying to catch a falling ruler. They held a 40-centimeter ruler just above the participant's open thumb and index finger, dropped it without warning, and measured where they caught it. The lower down the ruler, the quicker the reaction. They did this multiple times for both hands.
Ah, yeah, I think I've tried that. Okay, so quick tapping and quick catching. What about measuring hand-eye coordination?
For that, they relied on the trail-making test, often called TMT. It comes in two parts, A and B. Think of it like a connect-the-dots puzzle, but maybe a bit more challenging for your brain. TMT Part A is just connecting numbers in order 1 to 2, 2 to 3, and so on, as fast as you can on a sheet of paper. Part B mixes it up. You have to alternate between numbers and letters in sequence. So 1A, then 2B, 3C. It really tests your visual search, speed, and your ability to switch tasks mentally. They timed how long each part took.
Ooh, okay, that sounds like it would definitely need your eyes and hands working together smoothly, especially Part B with the switching. And finally, spatial skills. How do you test that mental rotation thing?
They used a standard test called the Purdue Spatial Visualization Test Rotation, or PSVTR for short. Basically, participants see a 3D shape, then they see several other shapes, and they have to pick which one is the original shape just rotated in space. So it's purely about that mental manipulation. Can you accurately picture this complex object turning around in your head?
Wow. Yeah, that sounds tough. Definitely test that 3D thinking. And what about the not-so-fun part, cyber sickness? How do they gauge that?
They used a common tool called the Simulator Sickness Questionnaire, the SSQ. It's basically a checklist. It lists 16 symptoms, things like nausea, dizziness, eye strain, disorientation. Participants just rated how severe each symptom felt, from none to severe, right after they finished the VR session, like a personal motion sickness report card.
Perfect. Okay, we've got the whole setup clear now, the students, the game, the tests. So let's get to the juicy part, the big reveals. What actually happened after that 30-minute Beat Saber session?
Okay, this is where it gets really interesting. The standout result was definitely for hand-eye coordination. This was, you could say, the star of the show. The study found a significant improvement in hand-eye coordination scores after playing the game. And the effect sizes were described as large and medium.
Large and medium effect sizes.
Yeah.
Okay, translate that for us. Does that mean it was a really noticeable jump, not just a tiny blip?
Exactly. An effect size tells you about the magnitude, the strength of the finding. So, large and medium effects mean the improvement wasn't just statistically significant, it was practically meaningful. It strongly suggests that playing Beat Saber for just 30 minutes genuinely gave their hand-eye coordination a solid, measurable boost, not likely just random chance.
Wow, that's actually pretty amazing for such a short time. Why do they think Beat Saber was so effective for this particular skill?
Well, the researchers also talked to the participants afterwards and got some qualitative insights. The students mentioned things like having to quickly tell the difference between colored blocks, using the correct hand for the correct color, and making really precise slashing movements in specific directions. It seems those specific game mechanics, the need for speed, precision, and matching actions to visual cues, directly honed the skills measured by the hand-eye coordination tests. And if you think bigger picture, this lines up really well with other research exploring VR for rehabilitation, like after a stroke or for conditions like cerebral palsy, where improving hand-eye coordination is often a key goal. So it's not just about games.
That connection to rehab is powerful. Okay, so a big win for hand-eye coordination. What about reaction time? Did they get quicker reflexes too?
For reaction time, the results were less clear-cut. While there were some slight improvements in the average scores, the study found no statistically significant improvement.
Okay, statistically significant again. So the small change they saw, it wasn't big or consistent enough to say for sure it was because of the game. It might have just been noise.
You've nailed it. The difference wasn't strong enough to confidently rule out chance, especially with just one 30-minute session. The study itself points to the short duration as a likely reason. Even the participants felt that maybe more sessions over a longer period, like a few weeks, might show clearer results. Other studies that did find reaction time improvements often used much longer VR interventions. So maybe potential there, but needs more time.
Right, makes sense. 30 minutes isn't very long to rewire reaction speed.
Yeah.
What about the spatial skills? Did slicing blocks make them better at mentally rotating shapes?
This was another area with no statistically significant improvement, although again, there was a slight nudge upwards in the average scores. This result was actually a bit surprising because some previous research has shown VR improving spatial skills.
Interesting. So why the difference here? Did the participants have any thoughts on why Beat Saber might not have boosted this particular skill?
Yeah, the qualitative feedback was revealing here too. Participants pointed out that the shapes in Beat Saber are mostly, well, simple cubes and blocks. They move fast, but they don't really require complex mental rotation like the shapes in the Purdue test did. So the game just wasn't directly training that specific kind of complex spatial manipulation. However, and this is quite interesting, some participants did mention feeling an enhanced sense of general spatial awareness just from being in the immersive VR environment. Like the act of being fully surrounded by the virtual world, blocking out reality, maybe subtly engage their spatial sense, even if it didn't translate to better scores on that specific rotation test.
That's a neat distinction. Spatial awareness from immersion versus spatial manipulation goals from the task itself.
Yeah.
So even without the big score jump, just being in VR might be doing something spatially. Okay, let's flip the coin now. Battling cyber sickness. How did the students fare with feeling dizzy or nauseous?
Right, cyber sickness is basically motion sickness triggered by VR. You get that disconnect, right? Your eyes are seeing movement, maybe lots of it, but your inner ear, your balance system, says you're standing still. That conflict can cause issues. And it varies a lot depending on the VR content. Fast camera movements are often worse the hardware, like screen refresh rates, and definitely the individual. Some people are just more prone to it.
Yeah, I know some people who can barely last 5 minutes.
Yeah.
So what was the verdict after the Beat Saber session for these students?
Mostly good news, actually. For the majority of the participants, the cyber sickness they experienced was rated as none to slight, pretty minimal. And importantly, any symptoms they did feel tended to fade quite quickly, usually within about 40 minutes after they stopped playing. So it wasn't a lingering problem for most.
That's really encouraging, especially for a fast-paced game like Beat Saber. Did anyone find it, I don't know, energizing?
Funnily enough, some did. A few participants described the experience almost like exercise, saying it helped warm them up, sharpen their focus, improve concentration. It seems the engagement factor was really high.
That's great. But was there any watch out or potential negative mentioned?
There was one point raised by a few students, 3 out of the 15 specifically. They brought up the potential for addiction, especially if playtime isn't kind of self-regulated. They linked it to their general gaming habits. And that really raises a bigger, important question, doesn't it? As VR becomes more common, how do we find that sweet spot? How do we leverage the amazing engagement and the potential benefits, like skill improvement, without falling into pitfalls like overuse or addiction? It's definitely something to keep an eye on.
Absolutely. That balance is key, especially if we start using VR more for training and education.
Yeah.
Okay, so let's pull this all together, the takeaway beyond the game. What's the main message from this deep dive?
I think the overall conclusion from this particular study is pretty positive. It suggests that for this group, using a commercial, off-the-shelf, immersive VR game like Beat Saber, the benefits, especially that significant boost in hand-eye coordination, seem to generally outweigh the adverse effects, like the mild and short-lived cyber sickness.
So a promising result for using readily available VR.
Oh, no.
But we do need to keep those study limitations in mind, right?
Yeah.
Small group, short session.
Oh, absolutely. Very important caveats. Only 15 students, just one 30-minute session. It's what researchers call a pilot study, really. They themselves say future research really needs longer experiments, maybe over several weeks, and definitely with more participants to confirm these findings and see if those effects on reaction time and spatial skills become more apparent. This is more like a strong hint, a promising direction.
Okay. So thinking about that future research, what kind of possibilities does this open up? Where could this lead?
Oh, tons of possibilities. You start thinking, okay, what other VR games might boost skills? Could we even design games specifically to target certain cognitive abilities more effectively? Maybe embed tasks that directly challenge spatial rotation within a fun game context. How does age play a role? Or someone's job? Or how much VR they've used before? There are so many different types of VR games out there now. Investigating which designs work best for training specific skills that could be hugely valuable for all sorts of fields, not just engineering, but maybe medicine, manufacturing, education.
I really just feel like we're just scratching the surface. So bringing it back to our listener, what does this all mean for you listening right now?
I think the big takeaway is that even a short, fun session with a popular VR game might be doing more than just entertaining you. This study shows it can have a real, measurable impact on important skills, like your hand-eye coordination. VR is moving beyond just being a novelty.
Yeah, it's not just games anymore, is it? It's potentially a powerful tool for sharpening skills.
Exactly. Whether it's improving coordination for intricate tasks or maybe enhancing spatial awareness for navigating complex spaces, these commercial VR experiences are emerging as a really accessible, engaging frontier for skill development. It has implications for how we learn and train, even for demanding professions.
Which leads to a final thought, maybe. As these immersive technologies weave more into our lives, what other everyday things might you be doing, maybe without even realizing it, that are secretly sharpening your skills? And looking ahead, how could we get more intentional about designing experiences, perhaps even beyond games, to really tap into and unlock more of our human potential? Something to think about as we all step further into these virtual worlds.